Question 3, find the side lengths of the triangle. So taking a look at this one, AB is pretty easy. We can see right here that it says 15. So that's going to be 15. If we want to label it, we can say units. AC is going to be X, but notice the tick marks that we've got going on right here, which once again means that those sides are congruent. So if AB is 15, then I know C, which is X, is also going to be 15 units. And then lastly, if we know X is 15, then I know I can plug that in, substitute it in right there. 15 plus 6 is going to be 21, so BC must be 21 units. All right, this next one, all of our sides have X in them. So we got to figure out an equation that we can make. And once again, I see that we've got some tick marks here. So that tells me that RP, segment RP is congruent to segment RQ. And that also tells me then I know that those measurements are equal. So I can set up the equation that 3x minus 0.4 is equal, since I know that those sides are congruent, to x plus 1.4. And once we have the equation, we can solve. So I can subtract an x from both sides. 3x minus x is going to be 2x minus 0.4 is equal to 1.4. Now let me add the 0.4 over to the other side. So that leaves us with 2x is equal to 1.8. Divide by 2, and I get x is equal to 0.9. But that's not answering the question. The question wants us to find the side lengths of the triangles. So I've got to plug that 0.9 into each of our sides. All right, starting with this top here. So if I do 3 times 0.9 minus 0.4, I type into my calculator 3 times 0.9, get 2.7. And then I subtract 0.4 from that, and we'll get a total of 2.3. So I'm going to just erase that real quick and say 2.3 is my answer on this side. PQ, if x is going to be 0.9, then 0.9 plus 0.1 is going to be 1 exactly. And the last one, when I plug in 0.9 for x there, add it to 1.4, we will get an answer of 2.3, which is good because we knew that the black tick marks right here for RP and for RQ say that they're congruent, so we should get the same answer for both of those. All right, STU. All right, so since we know that all of our triangles' sides are going to be congruent because they all have that black tick mark, we're working with an equilateral triangle, and I can pick any two of those and set them equal to each other because I know they're all equal, so it doesn't matter which ones I use. I'm going to use the 7n for sure because that's the smallest, or because that one does not contain a fraction. And we'll set that equal to, I don't know if it matters too much, we'll say 2n plus 3 3/4. Because I can't really do any math with 3 3/4, I've got to turn that into a fraction, an improper fraction. So 2n plus, and in order to do that, I'm going to multiply the big 3 times the 4 to get 12. 3 times 4 is 12, and then add 3 more onto that. So 12 plus 3 is 15. So then my final improper fraction will be that 15 over the denominator, which is 4, equals 7n. Anytime I see a problem with a fraction in it, I always want to cancel the fraction. That's my first step. So I'm going to multiply everything by that denominator. And since the denominator is 4, I'm going to multiply everything in that fraction by 4. So 4 times 2n is going to be 8n. 4 times 15 fourths, so that 4 and this bottom 4 are going to cancel out. So you're left with just 15. And then 4 times 7 will be 28n. Now it's a pretty basic problem, so we're just going to subtract 8n from both sides. And we'll get 15 is equal to 20n. And then divide by 20, and we'll get n is equal to 3/4. Okay, if I reduce the fraction 15 over 20, divide each of those by 5, I get 3/4. So, and since I know all of the sides are the same, all I've got to do is plug it into one of the sides, and that'll be my answer. I will plug it into the 7n because that's the easiest. So 7n so 7 times 3/4. And remember to multiply by fractions. We're going to get 21 multiplied straight across. So 7 times 3 is 21. 1 times 4 is 4. 21/4. I cannot reduce that answer, so I will just circle it and say that is my final answer. Remember, all sides then will be 21 over 4. All right, nice job. If this one was a little confusing, that's totally okay. Remember, if it's confusing because of the fractions and because of the algebra that we had to do here with the fractions and then getting 3/4 and plugging it back in, that's an okay problem to have. As long as you're able to set up this equation, which was that one side is equal to another side, that's what's super important with this problem. And last question. So given that the measurement of angle A, D, and G, so we've got all of these angles here that are 60 degrees, and we also know that we've got some parallel lines, so we know that AG is parallel to BF, which is parallel to CE. So with that information, how can I get at least 5 more? And I will tell you that all of these angles are going to be 60 degrees. So you don't have to get the same 5 that I do, but see if you can figure out why 5 of these would have to be the same. All right, well, I think the easiest ones to start with would be this angle 21 here, this angle 23. And how do I know that those are going to be 60? Well, they are corresponding to angle A. So I can say the measurement of angle 21 is equal to 60 degrees because it's corresponding angles. Feel free to abbreviate now that we're a new unit into it. So corresponding angles with angle A. All right, then I can also say the measurement of angle 23 is going to equal 60 degrees because it's corresponding angles with angle A. Similarly, I can see that this angle 24 and this angle 14 are going to be corresponding with angle G here. All right, and now those 4 are probably the pretty easy ones that you might have found right away. Next ones are a little bit tough. So to do that, we're actually going to draw and create our own parallel line. So we're allowed to, as long as we've got a point, we're allowed to make a parallel line. Now with that information, we can kind of do a lot with that. So I know that this angle is going to be 60 degrees as well because it is going to be, let me grab my laser pointer here, right? Alternate interior with this angle. So those two have to be the same. So then these two, well, let me say, this one actually is going to be vertical. So I know that's also going to be 60 degrees because that one is vertical with this one. And so then if these make up 60 and 60, then I know that these two also have to make up 60 and 60 because they are corresponding. So I can say that the measurement of angle 22 is going to be 60 degrees as well because of some corresponding with we're going to say it a little bit differently this time since I know that this is 60 as well. This angle right there, I'm going to say that's corresponding with 120 degrees. And I already know that that is 60, so I'm doing a little bit of angle addition postulate here by subtracting 60 to get that 22 is also 60 degrees. And we can keep going, we can find them all. But for right now, you did 5, and that's all we need to do. Good work.